Hey, what's going on, guys? Games here. So the last video we implemented a mini chess variant to be played on 8x2 chessboard, and actually this was intended to be played on the LCD screen. And down below here you can see the target device was supposed to be running our mini chess variant on. So a few words about the device. So this is the Arduino Nano based King1 emulator with an extended display capability. So instead of having 6-7 signal LEDs, we have the LCD screen instead. Other than that, the key monitor is from the original King1, and we have 16 keys to input the machine codes, some command buttons to run the program, go into addressing mode, to data mode, increment memory by 1, so yeah, go into address mode, go into data mode, stop the program, run the program, reset the device. So the idea is that instead of writing this chess program here on my laptop, instead on the laptop I would be using my laptop just to showcase how the development process works. I would be translating our program prototype in Python into 6502 assembly, and then I would be doing some hand assembly in order to convert 6502 assembly language mnemonics to 6502 machine codes, and then I will input those machine codes into this device, and then I will run them here. And in order to save my work, I would be making use of the serial monitor in the terminal mode. So I would be creating a paper tape on this device and send it back via serial port to my laptop. So the next iteration, like the next session when I'm going to be developing this, I can just load the data from the paper tape and keep developing from that point. So the entire chess program that was supposed to be running would be running on this guy, and it would be developed on this guy, and it would be debugged on this guy. So I hope that kind of makes sense. Now, just to demonstrate how the serial interaction works. So here we're in the keypad mode, which means that if I press the buttons on the device, it also gets transferred via the serial port, and vice versa. So if I just need to activate the window. So if I click buttons here, it just gets synchronized as well. But there is also so-called luxury mode, the TTY mode, and this comes from the original King1 monitor. So here we can do literally exactly the same thing. We can just go to a certain memory address, and we can also increment through the values. We can set up something there, but I'm not going to be using this. It's a bit of a cheating. So instead, I'm going to be doing everything on this keyboard. So the entire programming of this game is going to be happening on this keyboard, and I'm going to be using this serial terminal only to save the work I've done within the single video. Okay, so as far as we don't have Unicode graphics on this device, unlikely the PC, we need to encode our custom game graphics. So from the previous video, you might remember that we have only 4 pieces per side. So a bishop, a rook, a queen, and the king. So these are the whites, these are the blacks, or on the contrary, it's really hard to say. And yeah, it's arguable whether these pieces really look like the chess pieces, but assuming that we only have 5x8 pixels to represent as user-defined characters, that's all we have. And if you remember this from the previous video, so why we had exactly 8 pieces for both sides, because that's the number of user-defined characters that we can allow ourselves to define for the LCD screen here. Alright, so the scope of this video is actually to encode this user-defined graphics, store them to the 0 page, write a simple driver program to display them one by one, or probably display all of them, and then we'll just store the content of the 0 page as the paper tape, and we'll transfer it to via the TTY back to my laptop, so I could have stored that as a text file. So that in the next video we're going to be starting by loading this paper tape, so we'll already have this user-defined graphics in there, and then we'll start defining like the board array, the move offsets, and all the variables. Alright, so I will start by resetting my device because I didn't yet enter anything there yet. Do I really need, well, probably I can just restore these guys here as well. So we'll start by so we'll input the data for one piece, then this program run, and then another piece, then alter the Y register starting point, and so on and so on. So that's the way to go to test all the graphics. So what I want to test is that whether I did some mistakes while inputting this bytes and encoding manually or not. So if that's all fine, then probably, yeah, that just we can then just duplicate the code for, well, I don't know, probably there might be a slightly better workaround, like doing this in the loop. So yeah, probably the actual initialization of the graphics is going to be the topic of the next video already. So what I want to do for this one, because it's already going too long, I just want to make sure that I did encode this properly, and we'll hopefully see this these kind of images down below on the LCD screen. So without further ado, let's actually start. So let me see if it's kind of working. So yeah, 0, 0, 0, 0. And now I'm just inputting these values here. So I'm going to the data mode and I say 0, 4 and next. Now this one, 0E, 0E and next. Now 0, 4, next, 0E, next, 1F, next, 1F, next, 0E and 0E and 0E. And yeah, I think I don't even need the zero terminating characters here, so the white coin will probably start just right after. Well, anyway, let's go back to the dressing mode, 0, 0, 0, 0. So we have 0, 4, 0E, 0, 4, 0E, 1F, 1F, 0E, 0, 7, which seems to be okay. Now go into 0, 2, 0, 0. And now we'll start inputting our program here. So starting from this line, so I have it's the dressing mode now, so 0, 2, 0, 0, go into the data mode and A2, 0, 0, so setting up the X register to 1, and we don't need, oh my god guys, yeah, so I did some horribly wrong thing. We only have 2 bytes here, so these addressings are horribly wrong now. So actually this should be 0, 2. So yeah, I will just verify them from here. This would be a better way to go. So A2, 0, 0. Here we have A0, 0, 0. So this was A2. Then here, this is gonna be 4. This is gonna be 8. Nope. 8D. 17. 1. 7D. 0. And 0207 here. A9. A9. And 0, 0. 0209. Okay, so here we have 8D and 1, 2 and D0 and 020C here. Hence here we go into this 4C0C02. Okay, so here we go to 4C 0C 0C 02. Okay, and going back to addressing mode, so I need to verify the bytes. So A2 0 0 A2 A0 0 0 AD 17D0 A9 0 0 AD 12D0 4C 0C 0, 2. So far so good. And now if I did everything properly, if I go to 0, 2, 0, 0 and click start, it actually creates, it prints the white king, which is absolutely what we wanted to have here. Okay, so now we can encode the next piece, which is the white queen. So starting from here, I just stopped this program and addressing mode. So the address of 000F. Oh no, 0007, 0007. And this was, yeah, and the next one is, yeah, so starting from here. Okay, go into data mode, and here we go. So just save this. 04, 04, 04, 15, 15, 15, 15, 1F, 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 0E, 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 0E. Okay, going back to address and 0008. Let's verify 04, 04, 15, 15, 1F, 1F, 0E, 0E. So far so good. So now it kind of should be working. So 0, 2, 0, 0. And now what I need to change, well, as far as not writing the actual routine to initialize all this stuff, so I will just so I'll still, well, for now white queen would be like having the index of 0. Next it would be different, it would be 1, and just like we had in this program. But for now, as far as I just want to test whether the graphics goes properly or not, I just keep this stance and I just change the value in the Y register, and instead of 0 it should be the value of the white queen, which is 0008. So all I need is to change this byte to 08. So if I go to A200, A0, and this byte, I just set this to 08, and going back to data and 0200. And now if I did everything properly, it should draw here, it should draw the white queen. And it seems like it's a white queen. So far so good. Okay, so let's go and verify the next one. Actually, input and verify. So white rook goes next. White rook goes next. So this should be starting from, yes, 010. But anyway, 000F. Yes, 010. Oh, well, it has some data, but it's just preloaded into the emulator. These two values just don't need to care about them. So 000F. And next, so I just override these values. They are not important really. So go into data mode and 15. Oh no. Nope. 15. Okay. 1F. 1F. 0E. 0E, 0E, 1F, 1F. Go into data, 0010. Okay, so 15, 1F, 1F, 0E, 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 1F. What? Oh, I just press stop. Okay, address 0010, 15, 1F, 1F, 0E, 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 1F, 1F. Brilliant. Okay, and now the address should be 10. So for the Y register, so 0 2 0 0 a 0, and here it should be hexadecimal 10, like this. Going back to address 0 2 0 0, and if I now run, it should draw the rook. Let's have a look. Okay, so something goes wrong here. So the bottom is correct, but the top part is not. So I'm not really sure why exactly. 0 2 0 0 2 0 0 a 2 0 0 a 0, starting from the address. Well, the address should be correct. So I'm not really sure why is that happening, to be honest. So now, yeah, here 0 3, we have this. Yeah, this is getting a little bit strange, but yeah, let's calmly debug. So I'm going to, again, 0 0 0 F. So the next one is 0 0 10. So 15, 1F, 1F, 0E, 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 1F, 1F. So did I encode run 1 5? No, this is definitely 1 5. So it should draw like strange. This is strange. 0 2 0 0. Oh, I don't know. Now it works perfectly well. I don't know. Oh, probably I just ran this not from the wrong place, or I don't know. Yeah, but now it actually works as expected. So far, so good. Okay, so we got a rook, and now we are going to encode the bishop. So 0 0 17 and then 18. So address 0 0 17 and then 18. So go into data mode and we go for 0 4 0 4 0 E 0 E 0 4 0 4 1 E 0 E and 1 F. And the address is starting address is 18. So 0 2. Nope, 1F here is 001F, 1F. Go into address 0200. And here want the data of 18. 1 8 address and 0200 now should print the bishop. And here we go, we got a bishop. Tremendous. Okay, now let's keep going with the black pieces. So we're almost done, guys. So I'm going to addressing mode. Then we'll need to save this, for otherwise it doesn't make sense really. Part of just verifying this kind of works properly. So 001F. And the next byte, so here is, we were going for a black king. Okay, so here we have, so go into data mode, 0 4, nope, 0 4, okay, 0 E, 0 4, 0 4, 0 E, 15, 11, 1B, 0 E. And I hope this is correct. So now this the the pointer is hexadecimal 20. So 0200 hexadecimal 20, go into data, 20, address 0200, and we should see the black key. And it looks like a black key, believe it or not. Maybe not that ever most great, but I don't know, probably this is just fine. Looks like a key, right? Yeah, so let's just keep it like it is. We can always change the bytes, to re-encode the bytes a little bit, to change the difference, to change the appearance of the piece. But for now, this should be just fairly enough. Okay, now we go into 0027, 0027, and the next byte, starting for black queen. Okay, here, go into data, 04, 15, 15, 0E, 15, 11, 1B, 0E, and address 0200, and the pointer is 28. Go into data, pointer is 28. Go into address 0200, and now we should see the black queen. It looks like a black queen, more looks like a fork, but yeah, let's imagine this is the black queen. At least it looks exactly how we've defined the pictures. If you verify this one and this one here, they are the same. Yeah. Okay, so far so good. Now let's go to the black rook. So go into 002F, 002F, and the next 30. Okay. Go into data mode. So we go into 015, 1F, 11, 11, 0A, 0A, 11, 1F, and go into 0200, and the pointer is 30, is 30, 0200, run, and now we should see the black rook, and we do see the black rook. This is awesome. Okay, address 0037, and the next one. Okay, so now the final piece, the black bishop, and oh my god, we're gonna be done after. Just don't forget to create paper tape. Okay, so go into the data, 38, so 01 to 30. Oh no, it's the address, so sorry. 0E, 0A, 0B, 11, 0A, 0A, 11, 1F. And the next then is, this is 38. So go into here, 0200. Here is 38. 38, going back to address 0200. Now we should see the black bishop. Let's have a look. Oh my god, I did something horrible wrong again. Oh, the address is, or I don't know. Again, 0200 start. Yeah, maybe just, yeah, seems like an offset is a bit wrong. Okay, go into data 0200A200A0. Oh, not 3A, 3.8. This should be 3.8. Yes, there's a mistake here. Data 3.8. Address 0200 run. Yeah, now bishop. Whoa, hold on a sec. There is a 1 pixel lag here. Let's check this. Oh, it's not 0B, it's actually 1B. Okay, yeah, I just forgot to add this pixel. So this is 1B, 1B. So at the address 003A, at the address of 003A, there should be 1B. 1B. And go into here. Yeah, I know it's fixed. Now we have a full-blown black bishop. Okay, guys, this is the most significant part of the entire work. So now we need, if I just press reset or power off this device, we just lose the data that we've just came up with. So in order to avoid that sort of a thing, what I need to do is the following. So here I just, I kind of create, just new document, and I want to save it to desktop, mini chess, nope, here, and I just call it 0000txt, so it's the paper tape, or PDF maybe, like, doesn't matter really how to call it. So here we'll just here is the trick, here is the magic. So I'm going to the luxury TTY mode to the address 17F7 and go in there, so down below here, and the address that we need to write up to is 3F. So here I should say again like 003F, but bytes are swapped because of the little endian order. So here I say 3F and dot to enter this, and here 00. So if I go back to 17F7, 3F00, so these are the values. And now I need to go to the starting point of where to start sending the data as the paper tape, where the serial terminal. So it's the 0000 like this, and Shift Q, and here he's created a paper tape for me. So here is the paper tape, ends up here. So just grab this quickly, and here paste by clicking the single mouse button and save. So from now on, so like it just adds some zeros because it should be like 18 bytes there, like not 18 bytes, like 18 in hexadecimal. It's more than 18 in decimal. So the number of bytes in hexadecimal, then the starting address, then the bytes, and the 4 last digits is the checksum for this bytes. So as far as these are not used, they're just free, but once I'll reuse them later on, so they would be used as well. But anyway, now the idea is that well, I could have actually, well, probably just to demonstrate you this, because this is going to be used in the next videos. So same for let's just create a paper tape for the program part. I'm not going to be using this really now, but at least I'll start by uploading that in the next video. So just to give an idea where this kind of data comes from. So 0C02 is the starting point. So if I go to 17F7 back, and this time 0C02 and 17F7 0C02, and now I'm going to 0200, and if I now say Shift Q, it also creates the paper tape, but this time it's for the data, and I actually here I want to create another element and save it to 0200. So by memory address serves as yeah, and paste. Okay, this is lost, and like this, save. So here is the program. Again, like, so it's not used bytes here, but anyway. And now the most exciting part. So guys, I just press the reset. Okay, and now at 0000 we no longer have anything. And just to make it even more hardcore, I just turn off, I'm sorry, the power off, then power on. So it's for sure everything has been lost. So now what we can do, if we go, the terminal, the serial, okay, nope. It just closes the window, load, open. It just just closes the window once the device is kind of out. That's just how it works. But anyway, now we go to serial terminal mode, and I also have, so let me just copy my send utility that I've created. So in the desktop, I have in this code multi-key programs send pi. Yeah, probably could put this chess game here, and probably that's what I will actually do. Well, okay, maybe next time, maybe just next time. So just copy and desktop, chess, paste, and open the terminal. All right. So now, here I say Shift L, and it's waiting for data to be loaded. And here I say Python 3 send pi and 0000.txt. And okay, I need to make sudo because it writes to my TTY USB 0 path to file. Oh, it's PDF. And you see, like, it just sent the bytes back to my computer. And if I just go back to the keypad mode, then you should see here, let's say go to 0000, and you see, like, the bytes that we've input were kind of restored. So we go to 0200. Okay, just yeah, hold on a sec. 0200. Here we still don't have anything, so let's fix that as well. So Shift L, and now I want to load this one, and we just loaded the program that we've written, and okay. Okay guys, I'm sorry, I just ran out of memory in my smartphone. Okay, so, and now we're going to 0200. I just want to make sure if I did 02. Oh, okay, so we're still in the monitor, so we just go back. Yeah, now you see, like, our program bytes has just been loaded there. Yeah, it just ends from time to time, but it's okay. So 0200, and if I run the program, you see, like, it still prints that black bishop from the previous time. So this kind of means that we can, like, the next video, we can continue our work starting from this exact place, using this paper tape format to store what we have entered into this guy, into this one. So yeah, I know, I'm sorry for this video, probably was a little bit too long, boring, and tedious, but I promise that further on, it's gonna be more, it's gonna be, like, a bit faster and a bit more fun, because we're gonna be actually dealing more, like, with programming the game of chess. Well, not the real chess, but this mini chess variant. But anyway, this is gonna be fun, I hope, really. But again, like,
there's not only the matter of the graphics, but also it's the matter of the piece encoding. And assuming the current hardware setup, this is absolutely essential. So probably the next video will write a routine to bulk initialize all of this graphics, because now we've just been I was just manually resetting the value in the Y register, so probably it's a better way to do that in the loop, but I need to wrap my mind around that, because yeah, I just don't have another chance. I just need to make it once and forever, right? And then maybe we'll have a sort of a test program to print kind of all the available characters, like all the available chess pieces onto screen in a loop, and yeah, probably that is going to be the case. And then we'll go for encoding the chessboard with the pieces on it, and then we'll be adding the data by the time we'll need some more data. So I hope that kind of makes sense. Okay guys, this is it from my side. Thanks for watching. Until the next time, and take care.